All right, so for these exercises, we're going to be doing operations on functions, and eventually we're going to be doing composition functions. So the operations that we are going to work with would be adding functions, subtracting, which is the difference, multiplying or the product, and dividing or the quotient. The domain of the result of any operation is the domain of values found in both f and g. Okay. So again, this first example is going to be really nice because it's polynomials, right? So both f and g's domains, right? The domain here is minus infinity to infinity, and the domain for this function is minus infinity to infinity. Okay, so let's keep that in mind as we do these operations. So f plus g of x, I know that's written kind of strangely, but all that means is, as you see above at number 1, it just means take function f of x and add to function g of x. Okay, so f of x was 7 minus 4x plus, and I'm going to always do this in parentheses just to be safe, x squared plus 3x plus 2. That's our g of x function. Now, because this is addition, I don't need those parentheses any longer, and I can go ahead and drop them. And at that point, I want to add like terms. So x squared is all by itself. Then I've got 3x and minus 4x. That's going to combine to give me minus x. And then I've got 7 plus 2, or plus 9. Okay. That is the function f plus g of x. Now, what is the domain of that function? Well, it is by itself a polynomial, so it is not restricted. It has minus infinity to infinity. And the two functions that composed or put this thing together were also all real numbers for its domain. So the domain of this resulting function is x is an element of negative infinity to infinity. All right. What if we do f minus g of x? Well, that again just means f of x minus g of x. F of x was 7 minus 4x minus g of x, which was x squared plus 3x plus 2. So here that set of parentheses is important because now I have to distribute this negative around. So I have 7 minus 4x minus x squared minus 3x minus 2. Adding like terms, right? Minus x squared is by itself. Then I have minus 4x and minus 3x. That's minus 7x together. And then I have 7 minus 2, which is plus 5. This is the function f minus g of x. Again, this function is a polynomial, and therefore its domain is minus infinity to infinity naturally. And it's the two functions that were used to put it together also have that same restriction, which really is not a restriction. Therefore, the overall domain is minus infinity to infinity. Okay, so that's adding and subtracting. What about multiplication? So let's do f times g of x. So this really means f of x times g of x. So plugging in, f of x was 7 minus 4x. G of x was x squared plus 3x plus 2. Here we're going to need to multiply 7 by everything. So that would be 7x squared plus 21x plus 14. Then multiply the negative 4x by everything in here. So that's going to be minus 4x cubed, minus 12x squared, and minus 8x. Again, I would like to combine like terms. So minus 4x cubed is by itself. Then I've got 7x squared and minus 12x squared. That's going to be minus 5x squared. Then I have 21x minus 8x. That's going to be plus 13x. That was this and this. And then finally, I have plus 14. So this is that function. And once again, this is polynomial. It has no restrictions, and it's the two functions used to make this one also had no restrictions. So again, the domain is x is an element of all the reals, or minus infinity to infinity. Okay, so you're probably thinking to yourself, well, this doesn't seem so bad. Every time it's just minus infinity to infinity. Well, this is going to be our first case where that's not going to happen. So here I have f divided by g of x. And that really just means take the f function and divide it by the g function. Substituting in, this is 7 minus 4x divided by x squared plus 3x plus 2. Now, we would like to try to simplify this if possible. The best we can do is factor the denominator. So we're looking for two numbers that multiply to 2 and add to 3. Those numbers are going to be 1 and 2. So this will factor as x plus 3. I'm sorry, x plus 2 and x plus 1. Okay. Now, the two functions that made up this function had no restrictions. They were minus infinity to infinity. However, the new function, right, we're not allowed to divide by 0. So x cannot be negative 2 and x can't be negative 1. All right, so basically I just set both of those equal to 0 and solved. All right, that's how I got those values. All right, so that means that for my domain, I can start at negative infinity. I make my way up to negative 2 and I have to stop because I'm not allowed to equal it. Then I can go between negative 2 and negative 1. I'm not allowed to equal 1. And then finally from negative 1 on to infinity. So that's our first time where the new function has a new domain. And we'll see this happen quite often.